5.8, we are analyzing the graphs of polynomial functions. There's really only two things we're looking for in this lesson, so I have only 2 points in my outline here. I'll do just a couple of examples. But the first thing we're looking for, I actually have 4 different names, although these all refer to the same part of a function, of a polynomial anyway. Zeros, factors, solutions, and intercepts. It's 4 different ways to describe the same thing. So if you think about these words and how we use them, the zero of a polynomial is what you can stick into the polynomial to get the answer 0. So in this case, k is the letter I'm using to denote that. It's the number I can stick in for x that will make the polynomial equal 0. That's called a zero. Now we learned a couple of lessons ago that if we can stick in a number and it will make the polynomial 0, that means x minus that number is one of the factors of my polynomial. So each 0 for my polynomial corresponds exactly with one factor of my polynomial. And vice versa, each factor corresponds with 1 0. Now it turns out if we have an equation where a polynomial equals 0, or if 2 polynomials equal 0, we can subtract everything to one side and make it into a polynomial equaling 0. So we call that a solution to an equation, but it's really the same thing. All we did was take the polynomial, make it equal 0. Now we got to find what x we want. So it's a solution to the equation f of x equals 0. Those are the zeros, of which each one has a factor. And lastly, if we graph the polynomial, the places where the answer is 0, those are going to be the x-intercepts of our graph. So each x-intercept corresponds with one factor, which corresponds with 1 0, which corresponds with one solution to if we set our polynomial equal to 0. So these 4 words, or each one is a slightly different way at looking at the problem. You're looking for a slightly different thing, but it turns out they're all 4 describing the same number, the same part of this function. It's 4 ways to describe the same basic core idea. So that's actually half the lesson right there. Although we're also going to do a couple examples where we're identifying these. Although remember, we can identify them from factors. We can identify them from the x-intercepts of a graph. We can identify them if we have the zeros. It's all the same to us. The new thing we're going to talk about is turning points. You'll also hear these referred to as minimums and maximums. We're going to identify these graphically for now. Finding the value for maximums and minimums of anything that's not a parabola is really something that we leave till calculus because it requires calculus in order to do it. So we're going to be identifying these graphically. So we're going to produce a graph. We're going to look on the graph to find the turning points or the maximums and minimums. So here's my first example. This one is already factored. Now, if you have a polynomial that's factored, I don't actually recommend you graph it using a graphing calculator because it's going to take you longer to type in than it's going to take you to graph it once you get the hang of it. If you want to type this into a graphing calculator, or I'll be using an online tool called Desmos. If you want to type it in, you can. That may help you with the graph. But because of the fundamental connection between these 4 ideas, the factors that I have right here correspond to the x-intercepts of my graph. So I know my graph is going to go through -2 because that's the 0 that corresponds with this factor. And I know it's going to go through +1 because that's the 0 that corresponds with this factor. Because this has a multiplicity of 2, I'm not expecting the graph to cross the axis at this point. I'm expecting it to bounce off the axis and move back away from it. Now, this is a 3rd degree polynomial, and from the negative out front, that's a negative leading coefficient. So the leading term test that we learned way back at the beginning of this chapter tells me that this one is going to go down on the right and up on the left. So we already know I'm going to come down, I'm going to pass through here, I'm going to bounce off of this point and head down toward -infinity. To finalize my graph, then I'm going to find the y-intercept by sticking in 0, just because that's the y-intercept. So I get 0 plus 2 and 0 minus 1. That's -1, but it's squared, so that's 1 and that's 2. Multiply those, get 2, so -2 is my y-intercept. So I come down from infinity, I pass through here, I'm going to bounce off of this one, and there's a sketch of my graph. I'm not really concerned about the minimum might be slightly to the left or right of this. It might be a little lower than -2. But unless you're actually looking for the minimum, if you're just sketching a graph, I'm not going to be too concerned about that. If it's important to you to find the minimum correctly, I do recommend a graphing tool. This polynomial is bigger; it's 4th degree, so we're expecting it to go up to positive infinity on both sides. It can have up to 4 zeros. It would take me forever to find them all. Well, forever. It would take me a while to find them all. The nice ones are all multiples of 4, plus or minus, so there's really not too many to check. I could find them by hand, but I don't want this video to take a half hour of me looking for zeros. Well, okay, I could probably do that one in 10 or 15 minutes. So what I'm going to do is go to my graphing calculator, Desmos, which still has an old example in it. And I'm going to type this example in. X to the 4th plus 4x to the 3rd power plus 3x squared minus 4x minus 4. Now, Desmos does a very good job of making it very easy to find intercepts and extremes, maximums and minimums, turning points, because those are the things that we look for most commonly. So Desmos is going to let me find all of them very easily just by clicking. If you're using a Texas Instrument graphing calculator, you can find them. It's not quite as quick because the clicky interface is very nice. But if you need to learn how to do this on a graphing calculator and you don't already know, holler at me and I will upload a video showing you how to do that. So here I see I have my intercepts at -2. You can't see me writing down, but I'm just writing down the list. You'll see it in a second. -2, -1, and +1. Now we talked about multiplicity already. Notice the -2 here has a multiplicity of 2, so this accounts for all 4 of my zeros, because you have to count this one as 2. It's got a multiplicity of 2. So -2 is twice, -1 is once, and 1 is once. My y-intercept, depending on the instructions, you may need to find the y-intercept as well as the x-intercepts. So the y-intercept here is 0, -4. But note, the minimum is below that. Like I said, for the previous example, that can happen. So we have a minimum. That's a turning point. Note, so the graph is going down here, and then it turns around and goes back up. So that's called a minimum. It's at 0.366, -4.848. Those are approximate numbers, I'm pretty sure. And then we have a maximum here. The graph is going up, and then it turns to go down. So that's a maximum at -1.366, 0.348. And I already talked about it, but in case you weren't paying attention, this right here, where I bounced off the axis, that's a minimum. So there's a minimum also at -2, 0. So if I hide this graph, so I can show you what I recorded. In analyzing this graph, I looked for the intercepts first. There's an x-intercept at -2, at -1, and at 0. You could record these as points, -2, 0, -1, 0, and 1, 0. But if you label them as x-intercepts, you can get away with just writing the numbers. Honestly, if I said y-intercept, I probably should have just written -4. But I wrote that as a point. There's a maximum. I've recorded 2 minimums. I've recorded their points, and 1 maximum, which I've recorded its point as well. And really, that's all there is to it. We're going to use, for this lesson, we're using graphical tools to find the minimums and maximums. Like I said, if you're given one that's already factored and you don't want to bother to find the maximum, if your instructions are to sketch a graph, I'm not overly concerned about the minimums and maximums being exactly right. But if you are, throw it into a graphing calculator or take calculus and learn how to find the minimums and maximums by hand. Should get you started. Again, holler if you have any questions.